Hi students, in this video we are going to see about the experiment number 7 in data structures with C programming laboratory. Let us go to the topic. Design, develop and implement a menu driven program in C for the following operations on singly linked list of student data with the fields USN, name, branch, semester and phone number. So the task of this experiments are: first we should create a SLL of n students data by giving front insertion. Then display the status of the SLL and count the number of nodes in it. Perform the insertion and deletion at the end of SLL and perform insertion and deletion at the front of SLL. Demonstrate how SLL can be used as stock and queue. Finally, exit. So these are all the subtasks given here for this experiment. First, before moving to see the program, first we should understand the meaning of SLL. What is meant by SLL? SLL is nothing but singly linked list. It is a one kind of linear data structures. So it is coming under the type of linear data structure. So after the development of queues and stacks, it is developed as one of the linear data structure. So what is the format of this singly linked list means each element in the singly linked list is called as a one node. If you take one node, it has two parts. One is data part, another one is the next part. So data is nothing but that part is actually contains the value of that node, and next is another part that consists of the address of the next node in this SLL. Like this, every element, every node has connected with its pointer variables. So this is the one diagram. It shows the example of one single linked list. Here 3 is the first data. It should be connected with the help of head. So always the single linked list will start with the header node. So the header node will be pointing to the first element in the single list. Likewise, this 3 is as the first number, first element, it is connected with the head. Then next number 10 is connected with the first node, that is 3. How it is connected means it is connected with the next part of the first element. So the next part of the first element is nothing but 3, that is address of the next element 10 is connected here. Likewise, every nodes in this assembly are connected. This is another one example of showing a singly linked list. Here the head is having the address of 4800 and the first element is 10 is connected with the head. The next element, which is 15, is connected. How it is connected means it is connected with the previous node of next part. Okay, so the next part of the first node is as the address of the next node. So likewise, every node has its link to another node. That's what it is called as linked list. So here, these are the basic two examples of single list. How the insertions can be possible here means how we can insert one element in the single list means there are some possibilities of insertion. Either we can insert that element in front of the SLL, or we can insert the element at the end of the SLL. And also one more possibility is that we can insert the node in between the two nodes. So this diagram shows the how insertion is happening in the singly linked list, showing that how this node is connected in between the two nodes. So here, according to this example, 10, 20, 40, 50 are the 4 important elements, are 4 values connected here. Now I want to insert a new node called 30. How it is connected means first we should remove the next part of the previous node, that is 20 node, and that the next part of the 22nd node should be connected to the address of the new node. Then the address of the new node should be connected to the next node. So the next node is here 40, new node is 30, previous node is 20. So what are the 3 important tasks should be done here means first we should remove the next node of the next part of the previous node. That next part of the previous node should be connected to a new node. Then the next part of the new node should be connected to the next node. So these are all the important 3 steps should be followed in the insertion of a node in between the singly linked list. And how this can be done with the help of pointers means, here this diagram shows the examples of how this can be possible in the part of pointers. So how it is done means, here pointer is used for connecting the nodes in the previous nodes with the another node. So how it is done means, you can see the diagram, head is connected with a temporary node, then temporary node and the new node should be connected between the temporary node with the last node. So how it is connected means, we should make a new link over there. So how we can make a new link means, the next part of the temporary node should be connected to the new node. That is the one new link which is connected, which is made. Another one new link is from the next part of the new node, it should be connected to the next node. So likewise, instead of having a one link, old link, there are two new links has been created here. So that is what mentioned here in this pointer wise. Coming to the program, here what are the first part is to include the header files. What are the header files are required for this program means, there are three important header files are required. One is stdio.h, another one is stdlib.h, and third one is string.h. So these three are the important header files which are required here. Then struct node. Here this node is created with the help of structure in programming. So how it is created means, here it is created with a variable called as struct node into USN, SEM and phone number. So these three important memory variable structure variables are declared as integer. Then name of 20 is declared as character, branch of 20 is declared as characters. Then address of the next node should be created as another one node. So that is what it is given as a pointer variable here. So struct node of link is nothing but the address of the next node. Likewise, it is now created. Now next task is to, we have to create a one user driven program showing these subtasks. What are these subtasks means, first we should create a one single linked list along with the members specified. So what are the members specified here? USN, SEM, phone number, name and branch. So likewise, it has 5 important member. So what that 5 important members are given as arguments here in order to create a one user single linked list. Then void display, insert friend, insert delete friend. So these two are the insertions and deletions performed at the front end of the single linked list, and insert and delete and are the two important insertions and deletions operations done on the end of the SLL. Likewise, each separate user defined functions are declared here. So the definitions will be defined in the last part of this program. So after this user defined functions are declared, we move on to the main part. So here main part consists of, these are the variable declarations: int choice n, m, a, position, into USN, SEM, phone number, character, name of 20, branch of 20. Then it should start with the null part of the node. So start is equal to null. Likewise, this initialization and declarations parts are done here. Then move on to the menu driven program. It shows the numbering here. The menus are: 1 is to create, 2 is to display, 3 is to insert friend, 4 is to delete friend, 5 is to insert and, 6 is to insert delete and, 7 is to exit. Likewise, the choices are given, that accordingly the choices are scanned. The choices are read in the scanf statement. Then based on the switch choices, the cases will follow. Here case 1 is nothing but creation of a single linked list. So before going to create a single linked list, we must know the size of that single linked list. How we can get to know means, that variable is n. N variable is having the strength or size of the single linked list. So it is given from the user. So according to the size of the single list, each node will start storing its value. Here printf enter USN is given, then name, branch, semester, phone number. So likewise, it is going to create with a one node. So when we this according to the number of sizes, the create function will be keep on executing. Then case 2 is to display. So for displaying the function, one more user defined function has been written. It is, we'll see in the last. Then case 3. Case 3 is for insert. What is the case 3? Case 3 is for insert front. So we need to